So the next speaker, I think, is Jake. And you're using PowerPoint. So, hello. Lovely. Okay, so yes, my name is Jacob Filik. I'm a software scientist at Diamond, and I'm going to talk to you about web applications to support spectroscopy experiments, if I can figure out how to increment to the next slide, which is by the keyboard. So Diamond has a nice kind of portfolio of spectroscopy beamlines. We've got core XAS for high throughput operando experiments. We've got a high flux, high resolution beamline for kind of challenging samples. We've got microfocus beamlines for multimodal kind of XRF, XRD measurements. As part of Diamond 2, we're building a new fast scanning quick XAFS beamline, but this is not really a sales pitch for the spectroscopy group. I'm here to talk about web applications. So what needs do our spectroscopists have for web applications? Well, there's kind of two main features: simulation as a service, and, well, it's really important, I think, that every spectroscopist has their own reference database of standards. So they really want their own reference database of standards. So the spectroscopists at Diamond are part of a EPSRC-funded network called CONIX, and the aim of this network is to support synergy between experimentalists and theoreticians. If you're just measuring like ZANEs, so near-edge measurements, the best way to extract all the information from that spectra is to run a simulation to look at the electronic transitions. So the aim of this network was to really improve the relationship between these two groups and improve the use of theory at the facility. So this collaboration hosted networks and ran training seminars, but one of the outputs of the network was to make a simulation as a service portal. The funding for this project was continued in 2023 to carry on and expanding on this platform. I'm not part of the CONIX network. I was involved with this because in 2019, the spectroscopist came to me and said, "We need you to make a simulation as a service platform. When can we have it?" To which I replied, "I'm a Python data hacker who can write some desktop applications. I don't know what a simulation as a service portal is or how to make one." So they were like, "Is that more than 6 months?" I was like, "Oh, maybe." Fortunately, it's not just me. I'm not the only person at Diamond. There are strong teams of engineers to help me with this. So we put our heads together and thought, how can we actually make a reasonably lightweight, simple simulation as a service portal that these guys can use as part of their network? And the most challenging part of making a portal is making external-facing web application with auth-auth. Yeah, that doesn't necessarily come cheap. Fortunately, Diamond already had a externally facing web portal with auth-auth that was the MX Group's SyncWeb, that was the front end for the ISPyB database. And the information management team were kind enough to say we can have our own form as part of the ISPyB page that we could use to let users populate the information they need to build the input files to run these simulations. So then all we had to do was build a little fast API backend that we deployed on Kubernetes that took these input files, sent them to Slurm. On Slurm, we obviously needed some HPC that we could run these simulations on, and fortunately the spectroscopy group had some access to some nodes available on the SDFC's compute cluster, Iris, so we could deploy containerized versions of common XAS simulation packages like Orca and FDMNS, and just make quite a simple system. So when the Slurm job had run, the users were emailed the results, because the results were just pretty small text files at this point. So I'm going to say Kubernetes quite a few times during this talk. Don't get the impression that I understand what Kubernetes is. When we started this project, it was like, well, we need a server to run this on. Yeah, so if we need a server, we need money, and we give the money to a sysadmin. And then 6 to 12 months later, the sysadmin gives us an IP address and we've got a server. But like now we have Kubernetes, and it works totally differently. I find a cloud engineer. I say, I want to do Kubernetes. And the cloud engineer says, I need some YAML. And then I instantly get a computer. It's really good. I have no idea how the economy of Kubernetes works so that you can take YAML and convert it to computers, but it's really brilliant. There is a warning, though. If you ask for too many computers, they don't accept YAML anymore. You have to put Go templating in it, and then you're doing Helm. It's a really brilliant system, and this kind of allowed us to make quite a cheap MVP that gave them a simulation as a service portal. So if you're familiar with SyncWeb, you'll recognize the SyncWeb Gray, but this is the relatively kind of simple view form that they have that lets them input a structure and define some very basic parameters and run the simulation. So it has some strengths. It was really cheap to make. We've had it deployed for a couple of years now, and it makes a nice reuse of our existing systems. It's very quick to produce, and it's quite easy to keep it running. It has some very strong weaknesses, yeah? We're trying to make a user-friendly simulation as a service portal. This is supposed to be like a gateway drug for early career researchers to get into theory. So you want a really good user experience. You don't want to post a form and then hope at some time later you get an email. Like this is not brilliant UX. And because we're building on older existing systems, it's really hard to update and extend the user interface, and the integration between the services that join this together could be better. A lot of time has passed at DLS since we made this, and we recognize there's going to be a lot of web applications in the future, and we want to be careful about the web applications that we make and what technologies that we use, how we deploy them. So Diamond has actually invested quite a lot of time in writing policy and guidelines and best practices on how we make these systems and what they should contain. So there are lists of approved technologies, how you should use auth-auth, what your REST APIs should look like, what technologies you should use for user interfaces, and if you want these to be externally facing, all the things that you need to do around monitoring to make sure that what you're running is quite safe, yeah? So we've started the process of making the new WebConnex version 2. We're going to use the standard tools that Diamond recommends, so React, MUI, FastAPI, Postgres, SoIDC, these kind of things. We're just in the kind of architectural process now. We've started to slowly put together some sort of more friendly UIs so people can put in a chemical structure and actually see a rendering of what it looks like before they send the simulation off. And this is the kind of classical box and line diagram of what it's going to look like. We'll have an authorization proxy in the way that will put the authorization header so we can know exactly who is making the requests. We'll use Keycloak for authorization. The API will be FastAPI and Postgres. Front end will be hosted in Nginx using React, common tools. We'll still use Slurm and Aptainer and Singularity for the containerization, but we should have a nicer system where actually the users can see the output file being appended to as the calculation is running, and we can use things like H5Web to be able to render nice simulated XAS spectra in the browser when the calculation's finished. Yeah. So this is in progress. So the other application I was talking about is the XAS data repository. So again, we made this 4 years ago, and yes, there are a lot of XAS reference data repositories. There's a nice link in the XAS absorption web pages showing how many there actually are. The version we made back then used XDI, which is the common kind of data interchange format that spectroscopists used Django and SQL, but it had its own identity provider inside it. And Diamond policy is now very strictly, you don't have an application that has an identity provider in it. You use OIDC, and that is our single identity provider. So this has made deployment outside of Diamond really hard. In fact, it's only been an internally accessible application for the last few years. It doesn't meet policy anymore. We can't deploy it externally. We're going to have to rewrite it if this is something they want, yeah? So in re-architecturing the Connect system, we understand, we've read the guidelines, we've read the policy, we know how to do the auth-auth. We're going to basically take the same thing that we did for Connect, but we're going to use Larch to pass all the XDI files. And we started this work, and we have a nice web page. You can click on it, you can upload XDI files, you can view it, the standard things you would expect to be able to do for a database of standard data. But I mean, DevOps is great, yeah? I love DevOps. But this is a lot to maintain, and really in the end, the XDI files are text files. So they're asking me to maintain a repository of text files that they want to have anyone in the world to be able to submit more text files to that repository. They want to be able to review the text files to make sure the text files contain good stuff. They might want to be able to run kind of workflows on the text files to check the text files actually contain the right metadata and this kind of stuff. Are they basically asking me to write GitHub? Because I mean, not invented here syndrome is a thing, but it's a pretty big flex to start writing GitHub, yeah? 5 minutes, yeah. So instead of actually doing a big full stack deployment, if we just make a repo and put the XDI data in it, and we make a repo and we put the UI data in it, we can use a GitHub action to build the UI, copy the XDIs into the distribution folder of the static app you now have, run a quick Python script over it to generate an index, and upload all of that to GitHub Pages. And then we've just got a static system that functions in exactly the same way as our full stack deployment that we had to use on Kubernetes. We had to maintain and back up a database and the persistent volume that holds the data as well. But this is considerably cheaper. So this is on GitHub now. I've put a version on my GitHub Pages. The joy of this is if you have a repo of XDI files, you can just point this and change the GitHub action to point to your repo of XDI data, and you get a web page that you can view your XDI standards on. So any spectroscopist can make their own web page of XDI, of standard spectroscopy data for very little cost and basically zero hosting cost. So in summary, we're working on and updating our spectroscopy web applications. We're following, as best we can, central policy and guidelines. WebConX is a simulation as a service portal. It's currently very tightly tied to DLS. We're hoping that version 2 should be easily deployable at other institutions. So hopefully it'll just have a Helm chart or something that you can pull down, and it should hopefully, if configured right, work where you are. The XAS data repository, the version 2 we have deployed internally. Version 3 is on GitHub Pages, pointing at data from the XAS data library of Matt Newville and Bruce Ravel. Version 2 versus version 3 decision lies with the scientists. As I said, it's not just me doing these things. There is a strong science team leading the direction and strategy for what we make to support the spectroscopy team, which is Sophia, Dan Antonio, and Joshua, and Thomas Penfold. And there are many talented developers that help me lash this stuff together. Thank you.
Any questions?
No. So I haven't. It might be, it's not a term I'm necessarily familiar with. Yes, open data repositories and stuff is a very common problem, and we've seen a session just on metadata management. I mean, you could argue that, well, actually, when you properly have open data at your facility, you could just search for you could search for XAS references by tag and just download them all and build your own repository off that. What I'm aiming to what I hoped to do by this is build the cheapest possible solution, because then I can engage the spectroscopists on what metadata they want to be recorded and where and how, and they can start to build tools off this open data that they have. Whether there's a better system to do that with, I'm not sure.
Did you consider the use of code review feature of the GitHub to review data and in some corner cases make judgment whether it should make into the repository or not?
I mean, this is why I think GitHub is such a, because this is the thing we implemented in the full stack version, yeah, that a user would submit an XDI file and the spectroscopy experts would look at the data and review it and make sure that it had all the metadata they expected, and does it have a reference spectra and all this kind of thing. And it's like, well, this is a fraction as good as the review system that's on GitHub, and GitHub Actions letting you run effectively CI pipelines that check that Larch will open your XCI file, that it has all the headers that you expect to do and reports to the user in a nice way if it doesn't. This feels like a much more elegant solution. It's less elegant because your scientists will have to have a GitHub account, and there's often a lot of pushback from the scientists of like, I don't want to have to log into another thing. Like, why can't I want to be able to log into it with my Diamond account, but I also want my friend at another facility to be able to log into it. And it's like, okay, but I can't implement a separate identity provider. And whether I can use ORCID or not is sketchy. And when I say, can I use ORCID? You say, oh, I can't remember my ORCID login. Like, no, it needs to be my Diamond login, yeah? So it's an uphill struggle sometimes, but I think, yeah, it would be worth it.
So I'm actually going to steal Chair's privileges and ask one question as well. Give an idea of usage. Usage.
Of which?
The actual service and actually people running stuff.
The service and people running stuff. The
Well, it's actually-
XAS one or the Connix simulation as a
The
service?
simulation, that's a service.
Simulation as a service. So we had to, Iris used to be a HT Condor submission, and we had to switch it to a Slurm. Basically, I've wiped the database quite recently. It's not as high as the spectroscopies would like. So it's mostly internal people. I don't have we've ran this many jobs, I'm afraid, because should have got that metric. And part of the reason for the rewrite is that when we've engaged people on what's the user experience like, they're like, well, it's still not that great. Yeah, it actually builds the input file, so they can just download the input file and run it. So it's not where we want it to be.
One last question.
Super quick question. Are you using H5 for the plotting there?
So that
Yes.
plot is H5 Web. It's been like, it's wrapped inside a material component. So all the CSS is propagated from material. So the color scheme matches material.
Okay, thank you for using it.
No, thank you for making it. Yeah.
Okay. So if we can thank Jake once more, thank you.